Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually discussing the examples which were there in this particular gravitation chapter, which is the 9th chapter of 9th standard science subject. In this particular video, I'll be explaining the further concepts which are there in this particular chapter. So here in this video, we will try to understand what do you mean by mass and what do you mean by weight. So here we'll be learning what is the difference between mass and weight, and also some misconceptions we can remove in this particular video. So now we will understand what do you mean by mass. So always remember, mass is an intrinsic property of a particular object. So for example, you also have certain mass, I also have certain mass, all the objects which we are seeing around us have mass. So mass is basically an intrinsic property of any object, and this particular intrinsic property of object gives you the quantity what is there inside a particular body. So it is basically measure of quantity. So how much is there in that particular object? So that quantity, that intrinsic property of that particular object can be known as mass. So quantity contained in an object. So quantity contained in an object is an intrinsic property of that particular object, and that can be referred to as mass. We just came up with a term called mass. So now we have learnt about law of inertia in our previous chapter. If you have not learnt, you can go to my previous videos and see what do you mean by law of inertia, which is the first law of motion given by Newton. So now in that law of inertia, we know any object which has certain mass will resist to change its state of motion. So if a particular object is at rest, or if this particular object is traveling in uniform motion, so it will continue to move either in uniform motion or it continues to be at rest unless and until an external force is applied on this particular object. So if a greater massed object is there, then inertia will be higher. If lesser mass is there, then inertia will be less. So if mass is more, inertia is more. If mass is less, then inertia will also be less. That means mass is, so the inertia of a particular object is dependent on the mass of that particular object. So now after understanding this much about mass, so now we will try to understand what do you mean by weight. So weight is nothing but the gravitational force applied on a particular object which has mass. So now if I consider planet Earth, and on this planet Earth, if a particular massed object is there and mass of this object is m, then weight of this particular object is denoted as W. So weight is always denoted as capital W. It will be equal to the gravitational force of the earth on that particular object. So now acceleration due to gravity is g and mass of this particular object is m. So weight is mass times the acceleration due to gravity of that particular planet on which this particular object is lying. So this particular massed object, the object which has mass m, is under the influence of, it is under the greater influence of gravitational force of earth. So W is equal to mass times acceleration due to gravity, and this mass is the mass of individual objects. So here weight can be defined as force with which an object is attracted. So force with which an object is attracted, an object is attracted towards earth. So here because of gravitational force of earth, this particular object is attracted towards earth, and the amount of force which that particular object experiences because of gravitational force of Earth, that force can be known as the weight of that particular object, and that weight W is given as mass times acceleration due to gravity. So now, in order to calculate weight of a particular object on Earth, you can just multiply mass of an object with acceleration due to gravity. You will get the weight of that particular object on Earth's surface. Now, if you want to calculate weight of an object on Moon's surface, then this W can be written as Wm. So this will be the weight of same object on Moon's surface. And this W can be written as We. So this We represents weight of the same object on Earth's surface. So here m is the mass of this particular object. Here also mass will be constant. Always remember, mass is constant throughout universe. So for example, if m is the mass of a particular object, this particular mass of an object is constant in entire universe. So wherever this object goes in universe, its mass is always constant. It doesn't change. But weight changes accordingly based on the gravitational force of a planet on which that particular object is lying on. So here G is acceleration due to gravity on Earth. So I will write this as GE. And on Moon also mass is same. So I am just taking m, that is mass of this particular object. G in the place of acceleration due to gravity, I will take GM. So GM is the acceleration due to gravity on Moon's surface. And GE is the acceleration due to gravity on Earth's surface. So here gravitational force of Earth gives the weight for this particular object, that is WE. So that means here this particular gravitation, so this particular WE can be written as G into capital M into small m. So small m is the mass of object on Earth's surface, divided by, it is just kept on Earth's surface. So the distance between object and Earth is the distance between the center of Earth and to the object. So in the place of distance D, I can write radius of Earth RE square. So according to universal law of gravitation. So this is according to universal law of gravitation. So if you have not understood what you mean by universal law of gravitation, you can just refer my previous videos for this. So the weight of an object which is just kept on the surface of Earth is due to the gravitational force of Earth. So that's why this weight can be equal to GMM. So where capital M is the mass of Earth. So here I will just write capital ME. So mass of Earth, and this m, small m, is the mass of object divided by radius of Earth square. Now similarly, if this same object which is kept on Moon surface, then Wm will be equal to G into mass of Moon. So m will be there into small m. So this small m is the same mass of object which is same on Earth's surface, and also it is same on the Moon surface, divided by radius of Moon you have to consider. So radius of Moon square. So now here this you can call this as equation 1, and this you can call this as equation 2. So now if we divide equation 2 with equation 1, then equation 2 divided by equation 1 will be equal to Wm divided by We is equal to, here in equation 1 we have this, and in equation 2 we have this. So we are dividing equation 2 with 1. So that's why equation 2 will be in numerator and equation 1 will be in the denominator. So what is equation 2? GMM into m divided by Rm square. So here G into mm into small m divided by Rm square. So this is in numerator, divided by G me. So this is mass of Earth into mass of object which is kept on Earth divided by square. Here this particular mass which is there in denominator and this particular mass which is there in numerator can be cancelled, and this G can also be cancelled. So when this is cancelled, then Wm divided by We is equal to mm divided by Rm square whole divided by Me divided by Re square. So here I have written Rm, this is not Rm, this is Re. So Re square. Now you can substitute what is the mass of earth and what is the radius of earth and what is the mass of moon and radius of moon. So Wm divided by We is equal to, first you have to substitute mass of moon. So here in the numerator you have mass of moon divided by radius square of moon. So mass of moon here it is given to be 7.36 into 10 power 22. So 7.36 into 10 power 22 kg divided by radius of moon is given to be 1.74 into 10 power 6 meter square is there. So whole square. Whole divided by mass of earth divided by radius of earth is there. So this particular thing. So mass of earth is given to be equal to 6 into 10 power 24 kg. So 6 into 10 power 24 kg is the mass of earth divided by radius of earth is given as 3.84. So 3.84 into 10 power 8 meter whole square. So if you calculate this entire thing, you will get 0.165 as your answer. So 0.165 can also be written as 1 by 6. So approximately it can be written as 1 by 6. So that means ratio of weight on moon divided by weight on earth is equal to 1 by 6. Or if you bring this We to RHS, then Wm will be equal to 1 by 6 into We. So now if you bring this 1 by 6 to LHS, then it will be 6 into Wm is equal to We. So basically you are getting We is equal to 6 into Wm. So that means here you are getting Wm is equal to 1 by 6 We. So that means weight on moon will be 1 by 6 times less compared to weight on earth. Or you can tell this as We is equal to 6 into Wm. That is, weight on earth is 6 times more than the weight on moon. So for example, if 100 Newton is the weight, so if 100 Newton is the weight, why I am taking Newton? Because weight is the force. Always SI unit of force is Newton. So that's why weight SI unit is Newton. So that's why I am taking 100 Newton. So if weight of a particular object on moon is 100 Newton, so if this is the weight on moon, then this weight, the same object, if it is brought onto the earth surface, then weight of this particular object on earth surface will be 600 Newton. So that means on earth, weight of this particular object will be 600 Newton. The weight of the same object on moon surface will be 100 Newton. So that means 6 times lesser on moon or 6 times more on earth. Either way you can tell this. So this is just an example which I have given. So this is just an example. So if a particular object has 100 Newton weight on moon surface, then the same object on earth surface will be having 600 Newton weight. So now, after understanding about mass and weight, I'll just give a small example. On weighing balance, so if you have a weighing balance in your house, you can just keep that weighing balance, and if you stand on this particular weighing balance like this, whatever the reading you are getting on that weighing balance is really your mass or weight. So here whatever the weighing balance is measuring, is it mass or weight? So we don't know. Now if I ask this particular question to you, you will answer that the value which is showing on that particular weighing balance is weight of your body. But always remember, whatever the value which is displayed on that particular weighing balance is given in kg. So whatever this weighing balance measures, it is measured in kg. So weight is measured in Newton, but here your weighing balance is measuring in kg. So how is this possible? So always remember, this particular weighing balance always calibrates your mass based on your weight. So when you stand on this particular weighing balance, you are applying certain amount of force on this weighing balance, and that force you are getting because of gravitational force. So that means here this particular weighing balance is measuring your weight, which is equal to mass times acceleration due to gravity g. So whenever you stand on this particular weighing balance, it measures weight, and this measured weight is divided by acceleration due to gravity. That will be equal to mass. So that means whatever this weighing balance is displaying, it is displaying mass. So always remember, weighing balance is displaying your mass. So weighing balance is displaying your mass, but it is taking your weight. So whatever measurement this particular weighing balance is doing, it is doing your weights measurement. So measurement whatever is done by this weighing balance is done based on your weight. So that means when you stand on that weighing balance, because of that force, it will experience some amount of force. So that force is weight, and that weight is actually calculated by the weighing balance. But weighing balance, while displaying the results, it will divide that value with your acceleration due to gravity. So the weight which this weighing balance measures, so weight which this particular weighing balance measures, so weight which is measured by this particular weighing balance is divided by acceleration due to gravity g, which is equal to 9.8 meter per second square. Hence it shows mass of your body. So it shows mass of your body. So please read this again and again. So I have just explained this to give an insight about mass and weight, and whenever you are standing on your weighing balance, it basically measures your weight, but that weight is divided by acceleration due to gravity, and whatever the value is displayed will be the mass of your body, which is displayed in kg. So this is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.